NASA's Voyager 1 rocket, the farthest traveling spacecraft, continues its remarkable journey through space, transmitting valuable data from the deepest reaches of the universe. For nearly 50 years, this exceptional probe has revolutionized our understanding of space. However, recent transmissions from Voyager 1 have raised alarms, with disturbing signals that have left the space community in awe. Could these unsettling signals be the result of a technical malfunction, or are they evidence of extraterrestrial activity? Join us as we explore the truth behind these astonishing transmissions. Since the dawn of time, scientists have been fascinated by the mysteries beyond our planet. This curiosity led to the monumental launch of the Voyager 1 and Voyager 2 spacecraft, among other groundbreaking missions. These missions, discussed for years before their actual launch, began with Voyager 2's liftoff from NASA's Kennedy Space Center on August 21, 1977. Just 14 days later, on September 5, 1977, Voyager 1 followed suit. These twin spacecraft, each weighing 720 kilograms, about the size of a small car, were sent into space on a trajectory that took them through the outer planets. Throughout their extraordinary journeys, the spacecraft explored various directions and velocities, culminating in a significant moment on December 15, 1977, when Voyager 1 surpassed its twin Voyager 2. Since then, Voyager 1 has become an invaluable asset, providing us with a wealth of data and unraveling previously unknown space secrets. Before diving into the latest surprising discovery from Voyager 1 that has shocked the space industry, let's take a look back at the extraordinary images captured by the spacecraft during its crucial Jovian imaging mission in 1978. At this time, Voyager 1 was about 265 million kilometers from Earth, and from this vantage point, it transmitted a remarkable series of images. In January 1979, it embarked on an unprecedented 100-hour mission to capture time-lapse footage showing 10 rotations of Jupiter, resulting in 3,750 images that revealed the planet's magnificent rotation in stunning detail. Over the next few months, Voyager 1 ventured through Jupiter's moon system and made an astounding discovery: the presence of a small ring around Jupiter and 2 new moons, vastly expanding our understanding of the gas giant. To ensure safe passage and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were made. Voyager 1 then continued its stellar journey around Saturn, discovering 4 new moons: Mimas, Enceladus, Tethys, and Rhea. With the completion of its Saturn mission, scientists decided to conclude the planetary portion of the Voyager mission, propelling both Voyager 1 and Voyager 2 beyond our solar system at an incredible speed of 325 million kilometers per year. In January 1990, a new phase began: the Voyager interstellar mission. During this phase, Voyager 1 transmitted some of the most iconic images in space exploration history, including the famous family portrait of the solar system. This series of images, taken on February 14, 1990, from a distance of 6 billion kilometers from the Sun, included 60 images of the Sun and its planets, cementing Voyager 1's place in history. Meanwhile, Voyager 2 achieved another milestone in its journey, recording wind speeds exceeding 13,100 meters per second, the fastest ever recorded in our solar system. As it approached Neptune's blue methane atmosphere, Voyager 2 provided invaluable insights into this distant planet, revealing Triton, Neptune's largest moon, as one of the coldest known bodies in the solar system, with surface temperatures plunging to nearly -391 degrees Fahrenheit. Triton's fascinating features, including nitrogen gas-spewing ice volcanoes, also captured the imagination of scientists. These remarkable discoveries have significantly expanded our understanding of the vast variety and complexity of celestial objects in the farthest reaches of our solar system. But stay tuned, the Voyager 1 spacecraft has recently made one of its most alarming discoveries. Before we delve into that, let's review what it has achieved over the last 45 years. The accomplishments of the Voyager twins have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left researchers awestruck and challenged previous assumptions about these distant worlds. Once thought to be dormant and heavily cratered like our moon, these moons were found to be geologically active. Voyager 2, in particular, made several groundbreaking achievements, including becoming the first spacecraft to fly by Uranus in 1986. Just 3 years later, it became the only spacecraft to fly by Neptune. NASA has worked tirelessly to extend the lifespan of these remarkable spacecraft. Over the years, non-essential components and heaters have been deactivated to conserve energy, ensuring that the Voyager probes can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the researchers and engineers involved in this monumental project, the success of the Voyager missions is a source of immense pride, although it is also tinged with sadness as the end of an era approaches. Their tireless dedication has far exceeded expectations, and the wealth of data returned by the Voyagers has provided critical insights, sparking numerous scientific breakthroughs and inspiring generations of space enthusiasts. Voyager 1 and 2 were no ordinary spacecraft. They were meticulously designed as stable platforms, rotating more than 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the spacecraft captured images and data while traveling through the vastness of space. Even before their encounters with the outer planets, their exceptional imaging capabilities amazed both scientists and the public alike. The spacecraft began transmitting pictures of Jupiter even before arriving at the gas giant, with early images of Jupiter's swirling clouds and its iconic Great Red Spot captivating audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly made headlines. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected signs of volcanic activity on Io, which were later confirmed by images showing towering volcanic plumes and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force 100 times greater than Mount St. Helens, covering an area roughly the size of France. While the spacecraft's cameras were eventually shut down to conserve power and memory before their journey into interstellar space, it's worth noting that the images they captured did not include Mercury and Mars. Beyond the Voyager 1 and 2 interstellar probes, NASA has also operated other significant spacecraft, such as Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft in history. Voyager 1 continued its solitary journey for another 14 years after this milestone. At long last, on August 25, 2012, Voyager 1 entered interstellar space. Although no other space missions were nearby to witness this monumental event, NASA did not publicly announce this achievement until 2013. The success of the Voyager missions can largely be attributed to one brilliant strategy: gravity assists. These gravity assist maneuvers played a crucial role in propelling Voyager 1 and Voyager 2 on their daring journeys to explore the outer edges of our solar system. To reach these distant destinations and collect valuable data, the spacecraft needed more than just their own propulsion systems. They needed a boost. Gravity assists, or gravitational slingshots, provided that lift. Imagine Voyager 1 and Voyager 2 embarking on their monumental travels through the solar system. Instead of relying solely on their engines, they performed a celestial dance with the massive planets in our neighborhood. These giant planets, with their immense gravitational fields, acted as slingshots, accelerating the spacecraft on their way. This technique allowed the probes to conserve fuel while gaining the speed necessary to reach their various targets. The concept behind gravity assists is simple yet ingenious. As a spacecraft flies by a planet, it borrows a portion of the planet's energy. For example, when Voyager 1 passed by Jupiter, the gas giant's immense gravity pulled the spacecraft toward it, increasing its speed and propelling it on its way with a crucial velocity boost. However, achieving a successful gravity assist required precise timing and positioning. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot effect could have sent it off course. Thanks to the careful planning of the mission team, the Voyagers used gravity assists multiple times, allowing them to journey through the solar system. Voyager 2, for instance, utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These maneuvers were essential to the success of the Voyager missions, enabling them to travel beyond our solar system. The achievements of Voyager 1 and Voyager 2. The accomplishments of the Voyager missions are astounding. One of the most notable achievements of Voyager 1 was its time-lapse video of Jupiter, which captured 100 hours of the gas giant rotating. The spacecraft also discovered a new ring around Jupiter and identified 2 previously unknown moons, expanding our understanding of Jupiter's complex system. Voyager 1 also provided valuable data on Saturn and its moons. The spacecraft executed precise flybys of Titan, one of Saturn's moons, and discovered new moons of Saturn, including Mimas, Enceladus, Tethys, and Dione. Voyager 2, on the other hand, recorded the highest wind speeds ever observed in the solar system, exceeding 1,300 meters per second on Neptune. It also revealed Triton, one of Neptune's moons, as one of the coldest bodies in the solar system, with surface temperatures plummeting to -391 degrees Fahrenheit. In addition, Voyager 2 observed nitrogen gas and ice volcanoes on Triton, further deepening our understanding of these distant worlds. Perhaps the most groundbreaking achievement of Voyager 1 was its entry into interstellar space in August 2012. This milestone made it the first human-made object to leave the solar system, a feat publicly announced by NASA in 2013. The famous pale blue dot photograph, taken by Voyager 1 from over 6 billion kilometers from the Sun, remains one of the most iconic images in the history of space exploration. The role of gravity assists. The success of the Voyager missions can be largely attributed to the ingenious use of gravity assist maneuvers. These slingshot techniques, in which the spacecraft gained speed and changed direction by passing close to massive planets, were vital in enabling their journeys through the outer planets. By carefully planning these maneuvers, the mission team was able to conserve fuel and extend the spacecraft's missions far beyond their original capabilities. The Deep Space Network, DSN. Another key factor in the success of the Voyager missions was the Deep Space Network, DSN, a system of large radio antennas located in California, Spain, and Australia. The DSN enabled continuous communication with the spacecraft, allowing data to be transmitted back to Earth and commands to be sent to adjust their courses or alter instruments. This network ensured that the missions could continue, even as the spacecraft ventured billions of miles away from Earth. Current anomalies and investigations. Despite the remarkable engineering of Voyager 1, recent anomalies have raised questions. The spacecraft's unusual signals and the switch to a faulty computer have left scientists puzzled. Investigations focus on the Attitude Articulation and Control System, AACS, responsible for the spacecraft's orientation and communication. A malfunction in this system could explain why Voyager 1 is transmitting data through a malfunctioning computer. Additionally, space factors like cosmic radiation and extreme temperature fluctuations may have affected the spacecraft's hardware, leading to data degradation or memory errors. While less likely, the possibility of interference by extraterrestrial beings is also a subject of speculation, though this remains firmly in the realm of hypothesis. Future possibilities and legacy. As we continue to study the anomalies surrounding Voyager 1, the legacy of both Voyager 1 and its twin Voyager 2 remains firmly etched in the annals of space exploration. These missions have not only expanded our knowledge of the outer planets but have also demonstrated the ingenuity and resilience required to explore the vastness of space. Their planned mission end date in 2030 will mark the culmination of decades of scientific discovery and technological innovation. The data and insights collected by these spacecraft will continue to guide and inspire future missions, ensuring that the spirit of exploration and the quest for knowledge that drove the Voyager missions remain alive as we venture further into the universe. The lessons learned and the pioneering spirit embodied by Voyager 1 and Voyager 2 will continue to shape the future of space exploration.